So we say coming down is positive, so we have minus NA plus by mg cos theta this will be equal to m AGT. We have calculate, or we have written out, this is alpha L over 2, right? We have this over here. Can you do any more? We cannot do any more. So this is equation 1. So far it looked pretty glim, okay? So what do I mean by that? We don't know what is our MA. We don't know what is our alpha, right? Right? We don't know what is our alpha. Okay. So we have two unknowns to get rid. So unknown to remove. Are NA and what? Alpha. Okay. So we don't know what they are. Okay. So if you cannot do anything else, move on, do easy stuff. Dimension of forces in the n direction is equal to m ag n. Okay. So if you look at n, pointing towards A is positive. So this is FF. Then you have what? Minus mg sine theta. And then this whole thing will be equal to mass. AGN is equal to omega squared L over 2. Equation number 2. Okay. Now the situation gets worse. The more equation that we form, the more bad news we have. Yes or no? Right? So what we now need to find is we also don't know what is our FF. And then now, thanks to Eugene, we need to find out what is omega. So the unknown from equation number 2 are now what? FF and what? And alpha. Okay. Now, coming back to this problem over here, right? We are assuming at, okay, before I go on, this is a very academic question, okay? In real life, more complex stuff will be included, which is not seen over here. Like example, things like air resistance. Okay, we did not include that at all. Okay, so we really simplified things over there. Okay, now if I were to take this diagram, if I'm going to sketch when theta is equal to 0. Okay, so we see theta is equal to 0. So I'm going to sketch theta. I don't know why I do this question. It's just so abstract, but anyway, it's fun. When theta is equal to, come on, Eugene, seriously. When theta is equal to 0, okay. So we know for this case, when theta is equal to 0, okay, there is no slip. Okay, that's what we assume. As I said, this is a very fundamental question. You guys say, Eugene, you start to drop, I think it will start. So what will happen is this structure will start to rotate first, and then it will what? It will slip. You get what I mean? So it will initially start to rotate and shift, and then we'll have a linear motion with a rotation. Kevin, you understand what I mean or no? You're so quiet. I'm getting so worried now. You okay? You're very quiet today. Okay, I only remember Kevin. Okay. Why Kevin? I don't know. Kevin, you're looking sloppy. You used to come in a tie. So when theta is so abstract, okay? When theta is greater, is just is when theta is just a bit greater than 0. Okay. What will happen is the structure will, okay, I'm not gonna. The structure will just rotate. Okay. When theta, sorry with the handwriting, I'm getting too excited. Is just a bit greater than 0. Okay. And then when theta, okay, increase further, what will happen now is the structure now will what? Will rotate and will move in a direction. And at this point, okay, the support is no more in contact with the rod. Okay. So what I'm trying to highlight here, down here, you still have rotation about a fixed axis. So that is where we can use the N and T coordinate. Down here, no more. Down here is what we classify as a general motion. Meaning there are both rotation and linear motion. Okay, you guys can handle that problem. Okay, rotation, you guys are really good at it now. Okay. So from here, just to conceptualize, wow, powerful words, holy shit. So to let you visualize what is going on in a structure like this, okay? So the next thing we're going to do, I'm going to start on a new page because I need the free body diagrams or not I'll be lost. So we are going to take some mention about moment at point G. You can take moment at point A, the outcome will be the same. Okay, so we're going to take some mention about moment at point G, and this will be equal to summation at moment at point G kinetic. Okay, so we are going to take our moment at point G. So the only force that will generate a moment is NA is clockwise, so it's equal to minus NA or N sub A multiplied by L divided by 2. And this will be equal to minus also 1/12 M L squared multiplied by what? Alpha. Okay, because there's an alpha over here. Yes. This one? Yeah, this is kinetic. So you just look at over here, right? MAGT is not generating any moment. MAGN are not generating any moment because we take at point where? At point G. The only thing that is rotating is IG alpha. So it's the mass moment of inertia due to the angular acceleration of the structure. Okay. Now, if I were to take from point A, then there are two. Right? If I were to take from point A, there are two. Means I have to include IG alpha. Okay. I'm going to form the other equation and I want you to see this. Okay. So if I'm going to take, okay, if I'm going to take summation about moment at point O, sorry, at point A now. Right? At point A. And then this will be equal to summation about moment at K. So we're going to take our moment from there. So if we're going to take our moment over here, right, from A, then the equation will look different. The equation will look like mg, so clockwise, so minus mg cos theta, okay, mg cos theta multiplied by L over 2. And then the whole thing, right, so mg cos theta multiplied by 2. And then the whole thing will be equal to minus m AGT minus by IG alpha. Can you see the difference now? Okay, so if you take from A, you have to consider the mg cos theta. But the fact that I took from G, okay, I only need to consider NA. And over on the right-hand side, the kinetic, I only need to consider the IG alpha. Both answer, I hope, will be the same. Okay. So now, from here, let's focus on the left-hand side. Later on, if we have time, we do the right-hand side. So over here, we have NA L over 2 is equal to 1/12 mL squared alpha. So from here, we know that NA will be equal to 1/6 mL alpha. Okay, 1/6 L. So this will be our equation number 3. So knowing our what? Knowing our NA now. Okay, so if we look at our previous equation, okay, so you substitute 3 into equation number 1. Okay, so we're going to substitute equation number 3 into equation what? Number 1. Okay, I'll be done in less than a minute. Okay, so minus NA mg cos theta minus NA plus by mg cos theta, and this will be equal to ml alpha over 2. Okay, so it's minus 1/6 ml alpha plus by mg cos theta is equal to ml alpha over 2. We can get rid of the mass because the mass on the left-hand side, mass on the right-hand side is really a mass. So G cos theta is equal to L alpha over 2 plus by L alpha over 6. So we have our first relationship. So G cos theta is equal to 2/3 L alpha. So from here, we know that alpha is 3 over 2L cos theta. 3 over 2L. I think I missed a G. Okay. Okay. I'll see you guys tomorrow on Thursday. Those of you have to write your correction. I see you tonight.